Hello everybody, we're going to talk about the review today and just go over it. I'm going to go through, this video is going to cover the first page, the first 7 problems of the review. So in the first problem they're asking us to find the value of x. And so what I'm going to do is kind of think of my properties that I would be using to find the value of x. In this one, I know nothing else besides that it is a triangle. And so all of these are angles of the triangle, and I do know that all the angles add up to be 180. So for this first problem, my setup is going to be that 2x minus 3 plus 3x minus 12 plus 5x minus 5 equals 180 degrees, because all the angles add up to be 180. So I'm going to combine my like terms. All my x's combined together look like I get 10x. When I combine my numbers together, I get negative 15, negative 20. That equals 180. If I then solve this algebraically by adding 20 across the equal sign, 10x will equal 200. So if I divide by 10, x comes out to be 20 is what we're looking for that first one. All right, in the second example over here, I notice that I have an exterior angle, and so I know the exterior angle is equal to the sum of the two interior that are not touching it. So I'm going to add together x and x plus 10 and set it equal to the 4 times x minus 31. And so combining like terms, I get 2x plus 10 will equal, and I'm going to distribute right now, and it looks like I get 4x minus 124. If I then kind of move things around algebraically, I'm going to add 124 across the equal sign. And so I have 2x plus 134 equals 4x. Subtract my 2x across the equal sign. I get 134 equals 2x. And when I divide by 2, x comes out to be, I believe, 67. That is what we're looking for x, which is supposed to be 67, 64. All right. In example 3 here, we are talking about another triangle, and things that I know about this triangle is that there's two base angles are congruent, so that makes this guy isosceles, so that makes this side equal to that side. This piece of information is extra information. It's there to confuse you. If it did confuse you, then I guess it did its job. But what I do know is that these two sides are equal because they're angles opposite each other. And remember our property that talked about angles opposite the biggest angle were the biggest side. Well, if the two angles are equal, then the sides opposite them must be equal. So the way I would set this up is I would set it up as 3x plus 23 is equal to 6x plus 8. And so now I'm just going to solve this algebraically. I'm going to subtract 8 across the equal sign and get 3x plus 15 equals 6x. And then I'm going to subtract the 3x. And so then I'm left with 15 equals 3x. And when I divide by 3, x comes out to equal 5. All right, this guy again, number 4, is very similar to problem number 2. It is an exterior angle. So the exterior angle here is equal to the 2 interior. So I'm going to set it up as x plus 45 is equal to 2x minus 2. Solving algebraically, adding 2 across the equal sign, it looks like I get x plus 47 is equal to 2x. And if I subtract that x, 47 is what x is equal to, and that's what we were trying to solve for. All right, and then down here in example 5, they're asking us to classify the triangles by their sides and by their angles. Remember, the sides choices are scalene, isosceles, and equilateral. And angles, we have acute, right, obtuse, and equiangular. All right, those are my choices. So I'm going to go through and look at this. I notice that I've got two sides that are congruent to each other when I name them by their sides. Two sides congruent means isosceles. And then if I look at my angles, I have one right angle, so that is my choice of naming it by its angle. So this one is isosceles right. If I'm looking at the second triangle, second example here, I notice that all the sides are the same, so that has to be equilateral. And when all the sides are the same, all the angles are the same, so that would make this guy equiangular. All right. For part C here, I look at this guy and I can tell that two sides are the same by their markings, so I know that this guy is isosceles. And then by the angles, I've got two angles that are the same. That's because of the isosceles. And this angle looks like it's bigger than 90 degrees. I wish they would have given us a little more information there to make sure that it was bigger than 90 degrees, but I'm going to go with the looks of this, which is not necessarily always the best thing to do in geometry, but for this example, I guess we will. And so this guy is obtuse, because it looks like the angle is bigger than 90, so that guy is isosceles obtuse. All right, and so then this last one, they want us to tell what type of triangle it is, and it says explain and prove and all that stuff. So I'm going to first sketch out my drawing here. And so 0.00 would be right there. If I count over 6, I get a point right here. If I count over the 6 and up 6, I get a point right there. And so I kind of cheat because otherwise my drawing looks really bad. I'm going to do this. So here's my triangle that I'm dealing with. And so with that triangle, a couple things that I can tell. I can tell just by counting, since I've got horizontal, that this side's length is 6 and this side length is 6. So I know that this guy has to be isosceles. Because I have two side lengths the same. And if I went through, I could do the distance formula on these, but when in horizontal and vertical, all I have to do is count. If I want to find the length of this side to prove that it is not 6, which is probably what I should do, I'm going to label these A, B, and C. So up here, this guy was A, this guy is B, and that one is C. So AC, just by counting, is 6. BC, by counting, was 6. And so then to find out AB, to make sure that this guy isn't also 6, I'm going to do the distance formula. And so I subtract my x values from each other. So I'm going to take 6 take away 0 and square it. And then add on, again, my y values, 6 take away 0 and square it. So simplifying this, I get 6 squared plus 6 squared, which then gives me 36 plus 36, which is the square root of 72, which square root of 72 is not the same as 6 in length. The only way I would get 6 in length is this was the square root of 36, so since it's double that, this guy comes out to be 6 root 2, which is about 8 point something or other. So these guys are not the same length. AB is not the same length as AC and BC, so therefore this guy is isosceles, not equilateral. And then the only other thing that I need to do is prove what kind of angle we have in there, because they want us to prove the type of triangle. And I could go through. I'll do Pythagorean. I'll do the converse of Pythagorean theorem, which basically talks about if c squared is bigger than a squared plus b squared, we have obtuse. If c squared is equal to a squared plus b squared, then it is acute, or it is right. Sorry, that's what the whole Pythagorean theorem is all about. And if c squared is less than a squared plus b squared, then the thing is acute. Now, you could have done this by using general properties and things like that of triangles and get the same answer, but this, I think, is the quickest since we already have the side lengths. So to do this, I'm going to say, okay, my c is, so basically c squared is, we're talking about ab squared and how it relates to ac squared plus bc squared. Those are my a, b, and c, and I know ab is my hypotenuse because it's the longest side. It's bigger than 6 and 6, so I'm going to take square 72, the square root of 72, and that guy is going to be equal to 6 squared plus 6 squared. And in this case, square root of 72 squared is 72. This is 36 plus 36, And so 72 is equal to 72 when I combine those together. So going with my properties over here, this guy is right, and you could see it by the drawing, but I wanted to make sure, and that's what they're talking about, to make sure I prove it, so this guy is isosceles right triangle. All right, I will come back with the rest of the examples from here. I'll talk